Here's a quick video on how we make this ESP32 blink.
I'm using the ESP32 WROOM Thing Plus C by SparkFun. Like almost all embedded systems, the ESP32 uses something called a memory mapped I/O or MMIO. And this pretty much means we treat the hardware of the ESP32, like the sensors, timers, GPIO pins, and other peripherals as memory addresses in the RAM. So to control our hardware and to get the GPIO to blink in our case, we have to do operations on these memory addresses. If we look at the ESP32 datasheet, the memory block that controls all GPIO pins starts at the hex address 0x3FF44000, and it goes all the way till 0x3FF4 4FFF. And from that starting point, we have different registers at specific offsets to control different things. So a couple other registers that I want to point out are the GPIO out W1TS register, which is the setting register, which is offsetted 8 bits from our base address. And we also have the clear register, which is offsetted 12 bits from our base address. We also stored the GPIO out register in our code, which is 4 bits from our base address, though we won't really be using it, which I'll get into a little bit later. It's added all the registers that we found in our data sheet to our code. One register which I didn't mention was the GPIO enabled W1TS register. And the reason why we have to use this is by default, the GPIO pins of our board are set to input mode to prevent, kind of like a safety feature to prevent any short circuits or anything that could go wrong. So we have to actually set the enable pin to 1 to signal that now this GPIO pin is the output and we're writing to it. And this will prevent further problems down the line. So one thing that I want to mention is the ESP32 is a 32-bit processor. So this means that its GPIO peripheral is controlled by a 32-bit register where every single bit from 0 all the way to 31 is hardwired to a specific GPIO pin on the outside of the chip. So that means bit 1 will control GPIO 0, bit 1 will control GPIO 1, and so on. So this gives us intuition into our shifting logic. So the LED pin that correlates to the blinking in our ESP32 WROOM is GPIO 13, which means that we target the 13th bit in that register. So we take the 1 which represents our on signal and we use a bit shift operator to slide that 1 from the first position all the way over to the 13th position to perfectly align our bit mask with the hardware pin. So this is pretty much the equivalent of let me get it real quick, of doing something like this, where we have taken this binary and we have put a 1 in the 13th bit position. Say that we wanted to, instead of owning the first bit, instead of owning the 13th bit, we wanted to on the first bit, then we would just change it like that. So each of these binary bits corresponds to it has a 1-to-1 mapping with its GPIO pin. So we can pull that back. So this would be the equivalent of just shifting by 1. But in this case, because we're using GPIO pin 13, we have created a bit mask that shifts the 1 bit all the way to the 13th spot of the binary. So we might think that we can just simply just write this 13th bit into the GPIO out address, and with that we're done. We don't need all of these other registers. But the one problem that arises from doing that is, sure, we do write the 1 into the 13th bit, but we also write zeros into all of the other GPIO output bits. And this creates lots of problems when we have multiple GPIO pins that we want to turn on and off, and we're doing more complex stuff, which is not true in this case. So to solve that problem, we have these 2 smart registers, which are W1TS and W1TC for clearing. And these registers pretty much help you write to the bits without affecting any of the other GPIO bits in the register. So writing 1 to the 13th bit won't affect if there's ones in any of the other positions of the output register already. So these are just much smarter and safer registers to use in this case. And one thing that I want to mention with these registers is all these registers are doing is they're triggering electrical pulses to write in and change the value of the GPIO out address in a much safer way than if we did it ourselves. They're not actually storing any data or values. So if you write a 1 to them, to the W1TS register, it knows I should change the bit that we wrote a 1 to on the GPIO out register, but it itself won't store any data or that one value after doing so. Okay, so now let's go over our main code. So the first thing, like I said earlier, is we want to enable the register pin. And then when we enter the while loop, we set the register pin to our LED pin bit. So we're just telling the W1TS register to write to this 13th bit, write this 13th bit high for the GPIO out register. And now we've kind of used a real-time operating system library to help us with the delay. But now we're going to have a delay of 500 milliseconds. And then afterwards, we're going to do the same thing with the clear register to turn off the LED. And this will run for as long as the ESP32 is given power for. And yeah, that's the entire logic. And that's how we get our ESP32 blinking.